Welcome to EKLAVYA Institute of Science. Myself Gautam Banerjee, going to take up physics with you. The topic is projectile motion. Now projectile motion itself, when we say projectile का मतलब हुआ projections, throwing something at an angle. Now when we throw something at an angle, two ways are there. दो तरह से हम करते हैं. One, for example, like firing a gun, a bullet from a gun. Second, from a top of a tower, we are throwing a ball or anything horizontally. Now, this is horizontal projectile and this is oblique projectile. Oblique projectile means projecting any object at an angle, theta. Both giving an initial velocity u. Now, we need to understand motion, projectile motion, more comfortably. Projectile motion first is a two-dimensional motion. How it is two-dimensional motion? Because it is taking both the coordinate axis in consideration. As we have learnt earlier about the two-dimensional motion, we know any motion which is being described by any two of the coordinate axes, XY, YZ or XZ, they actually form a 2D motion. 2D motion, example if we talk about, best example, firing a bullet from a gun at an angle. ये है वो oblique projectile. Badminton, hitting the shuttlecock. Now the path of the shuttlecock ये है वो ऐसे. Again 2D motion, projectile motion, oblique projectile. Now क्यों 2D? Because at every point, if you see, both the axis is in consideration. X, Y, X, Y. Now, coming to what is projectile motion? Exactly when we say a motion is projectile, we have discussed it is a 2D motion. Now, when we say it's a projectile motion, any body which is once thrown with certain initial velocity, and it covers certain distance and falls under the action of gravity. That means, suppose if we ask or if we discuss about the motion of a rocket, although the path is just like this, it is falling like this might be. No. But is it still a projectile motion? No. Although its direction is like this, it's not that, because once it leaves the base, From there it moves like this. But it's still not a projectile. Why? Because it is governed by an external machine, jet. So it is not falling under, motion is not under the action of gravity. So motion of rocket is not a projectile motion. Although it looks like a projectile, but it is not a projectile motion. Now, there are so many examples we can quote. Javelin throw, that is an example of a projectile motion. Now, the name projectile we have understood. What is a projectile motion we have understood. Now, there are few qualitative part and the quantitative part which we need to do, like we need to find out few calculations and formulas for two types of projectile. Let's start with horizontal projectile. Horizontal projectile motion. Now, when we talk about horizontal projectile motion, let's find out few parameters for this. This is how a body is being projected with the velocity, initial velocity u, from a height h. Let's take, this is the ground reference, and this is touching the ground at A. So this distance OA is denoted by capital R. What is this? It's known as range. Range, that is from the originating point till where it lands. That is the distance R. Now, there are few parameters we need to find out. How to find out? How to discuss them? The first one, let us take one by one, because as we know, this is taking into consideration of two coordinate axes. So why not? Let us take one by one motion. Number one, let's take the horizontal motion. Let's take a horizontal and consider any point P. This is an instantaneous position we have taken. Now here, suppose it is coming with a velocity v. That's the basic thing. Furthermore, this component has been divided into two, that's Vx and Vy. Obviously, from here if you say this distance will be x, and if you say this distance will be y. So this is how also we can do. Small distance y, and this is a small distance x. Now, when we take horizontal motion, one characteristic feature, horizontal motion is always a constant motion. That means horizontal motion, it is always uniform. Motion is always uniform. Hence, what does that mean? U along x is equal to v along x, which is equal to u. Hence, acceleration along x will be 0. As there is no change in velocity here, So acceleration stands to be 0. We need to find out, suppose distance x. Using the equation, second equation of motion, x equal ux. X is, it's just a subscript. Ux means initial velocity or velocity along x direction. Ax means, this x is again a subscript, means acceleration along x-axis. Let's take the equation, write it. X equals to uxt plus half axt square. Where is this time? This t is instantaneous time. That's time. That's better we write down. T stands for time. For that particular point. Now, this is coming from second equation of motion. X, let's take it as x only, as it is x. Ux initial is, we have taken u time t. Now acceleration 0, so hence this part is 0. So what we got, x equal ut. So now if we need to find out the time taken, so that t we can get by x upon u. This time is the time taken by the projectile to reach at any instantaneous point, say P. Now, horizontal motion we have already discussed and we have found out a parameter. Parallelly, let's take the vertical motion. Vertical motion, when we talk about vertical motion, that vertical motion may, let's take u along y-axis as initial vertical velocity. But vertically, this is a free fall. In horizontal projectile, vertical motion, so initial velocity, we can see it is being projected along horizontal, so no vertically. So uy is actually equal to 0. Now when it is falling under the action of gravity, so let's take ay as equal to g, that is acceleration due to gravity. Y is the distance covered and time during the same time t. Now we have to remember during the same time t. So let's use the format now. So by this time, let us find out or take the vertical motion in consideration. So again using the equation, second equation, y equals to uyt plus half ay t square. Uy is 0 plus half g, and what is t we have found out, that is x upon eu during the same time, because it is a 2D motion, comes out to be x square upon u square. What we got finally, y is equal to gx square upon twice of u square. Just note down this. Hope you have already noted down the previous one. Now note down this. This is an equation. This equation is known as equation of trajectory. Equation of trajectory. Path. Trajectory का मतलब होता है path. The path actually covered by this. That is called trajectory. Now, so in order to prove whether this is a horizontal projectile or not, this equation needs to be satisfied. Once this equation is satisfied, that means horizontal projectile motion. Now, you might have noted till here. From this, we can find out few more parameters like velocity, total velocity at any point, say P, how we will find out. How to find out total velocity at any point P? That's the first thing. Time of flight, that is another thing. So let's find out first the time of flight. Now, time of flight. What is this time of flight is all about? It is denoted by capital T. Time of flight means the total time taken by the motion, by that object to fall onto the ground. So that is what is called time of flight. Now, when we are finding out time of flight, which equation we need to take? See, this complete motion uses, because since we have divided into two parts, horizontal, vertical motion. Horizontal motion, linear motion, vertical motion, again a linear motion. If you check it by a reference frame. So we are using Newton's equations of motion. Now, obviously time of flight, that means the total time it was in air till it touched the ground. So obviously we are going to take the vertical motion in consideration. Again, let's put the same thing, uyt plus half ayt square. Second equation of motion we are considering. So y equal to uy, again 0, as already we discussed that vertical motion, the initial velocity along the vertical motion is 0 because it's a free fall. Half ay is g, and this t has to be removed by t square, where because we are finding out the time of flight now, the complete time. So what is this y? Instead of y, now we are supposed to use the complete h. So h will be equal to half g t square. Therefore, t will be under root of twice of h upon g. Twice of h upon g. This is another formula we have found out for time of flight. That time was an instantaneous time at this point P. This is for the complete motion. This is what is time of flight we have found out. Let's move on to the distance. The distance from the originating point till it touched the ground. That's called horizontal range. Hope you all have noted down this derivation. Next parameter, let us find out, जिसको range कहते हैं. Let's proceed on again with the range. Horizontal range. Now, when we write down this word horizontal range, which equation needs to be taken into consideration? Very interesting. You might be thinking, very easy, horizontal range, that means we are going to take the component, that the horizontal component of the motion. And what is the horizontal component? Fine. We know ux is equal to u, and time period just now we have found out under root of twice of h upon g, that's all. Equation x is equal to, we know that horizontal motion is a constant motion. So uxt plus half axt square. But interestingly, this ax here is 0, so this part is 0. Therefore, r will be equal to, instead of writing xr, ux is u, and this t will be capital T, which is under root of twice of h upon g. This is, we have found out horizontal range. Please do note this. After this, definitely we would be like to find out, we would be thinking ki, suppose we need to find out the final velocity at any instant. How to do that? Good one. Once you note this, remove. Let's proceed with that velocity of the particle at any instant. Fine, that is called the final velocity. Remember your vector knowledge, just recall. We can see this. By this we can understand, we will be, as we have found out in vectors, resultant. So resultant, how we find out? We are using the same formula for the resultant here for finding out the resultant of the velocity. V is under root of Vx square plus Vy square plus 2 Vx Vy cos theta. Now you might be thinking why I didn't write that. Good. Between the two vectors, the angle is 90 degrees. So cos 90 stands to be 0. Hence that component is 0. We didn't write it. Now Vx, as already it is a, I told you, x along horizontal motion. So Vx is obviously ux, and it is an uniform motion which is equal to u only. So we have got Vx equals to u. We need to find out Vy. First equation of motion. Using first equation of motion, T, Vy, Uy. Initial velocity along y is 0, we know, that is simply gt. Now, therefore, velocity at any instant is under root of u square plus g square t square. This is the formula for finding out velocity at any instant. This means velocity at any instant. So, today we have discussed a topic, small topic of horizontal projectile motion. Now another topic we need to discuss after this, that's what I told you in the next session, that is oblique projectile motion. Till then, I would suggest you to practice these derivations, whatever we have done, and do some numericals from the required books, whether it is NCERT or जो भी आप लोगों के पास books है उससे आप करें. Then we'll get back again with oblique projectile motion. Thank you and stay well.